This is the second video in the Year 10 Science Motion series. First video we looked at speed, distance and time. I'm going to be looking at some more formulas in this video. So having just defined speed in the last video, speed, if you remember, is v, which equals distance divided by time. Speed is a measure of how much distance, how much ground you cover in a specific amount of time. We use the symbol V and not S because S is used for something else in physics. Okay, we use V for speed. Speed, distance, time. Distance usually measured in meters or kilometers. Time typically in seconds, or could be hour as well. Speed, meters per second, kilometers per hour. I want to introduce a new concept now called acceleration. Acceleration, we've all heard the phrase, look at that car, it's accelerating or it's decelerating. Acceleration is basically a measure of how fast the velocity changes. So it's a measure of how fast the velocity changes. For example, if you're pressing your foot on the pedal, the accelerator pedal in a car, and you're ramping up the speed, the car's accelerating, okay, because the speed's increasing over time. If you take your foot off the pedal and you apply the brakes, the car's decelerating. Okay, the velocity is getting less and less at the time. How do we write this mathematically? So we use the symbol lowercase a for acceleration. First letter of the word acceleration. That's equal to the rate of change of velocity over time. So rate of change, I'm going to use some notation here. Delta V over delta T. Some of you might be thinking, what on earth is this triangle thing? This is the Greek symbol, capital delta. Think of a river delta from geography studies. A delta is a triangle shape. Delta means, in maths and physics, change in something. So delta, so the triangle here, the delta V means change in V, change in speed, or velocity in this case. And the delta T means change in time. Now velocity, haven't really defined it. Velocity is the exact same thing as speed. This is another new idea for you. Same thing as speed, but with a direction. Velocity is used in things like navigation, in aviation. Let's suppose you're flying a plane and you're told by air traffic control that you've got a high velocity wind vector coming in from the west at 10 meters per second. So, 10 kilometers per hour. 30 kilometers per hour, let's say, if you're flying a small plane. So that's what velocity is. Velocity is speed, but with a direction. It's called a vector. A vector is something that has size and direction. So I'll give you an example. Let's say if I said 30 k's per hour, that is speed. But if I say 30 k's per hour west, that's velocity. Okay, velocity has direction. Speed doesn't have direction. This is called a scalar. A scalar quantity is just a number. Okay, 10 degrees Celsius is also a scalar quantity. 10 meters, that's a scalar quantity. A vector quantity, vector, you can think of it as an arrow. It's something that's got size and direction. So you can think of wind speed. That's a vector. It's got size and direction. Force is also a vector. Let's say 10 newtons applied in the west direction. So acceleration's change in velocity over time, change in time. Let me write this again. This is the same thing as V minus U over T. TF minus TI. I'll explain this now. Change in velocity means the final velocity, which we write as V, minus the initial velocity, which we write as U. Now, who came up with these symbols? I don't know. That's just how it is in physics. Initial velocity. I'll give you a simple analogy. Think of temperature. Let's say, I don't know. I have a thermometer here, and it's, I don't know, times 0 seconds. And the temperature at this time is, I don't know, 10 degrees Celsius. Let's say I'll wait for 10 seconds. Temperature goes up to 20 degrees Celsius. What is the change in temperature over time? Let's say delta T over delta lowercase t. Here's how you work it out. Well, to work out the change in temperature, you have to subtract, right? Final minus initial. So final is 20 to T sub F minus T sub I over T sub F minus T sub I. T sub F, this is 20. T sub I is 10. Final time, that's 10 seconds. Initial time, that's 0 seconds. So doing the maths, the change in temperature is simply 10 over 10, which is 10 over 10. So 10 degrees Celsius, I should be writing units, but that's right, it doesn't matter in this case. 10 degrees Celsius per 10 seconds, and that gives you 1 degree Celsius every 1 second. There's a change of temperature of 1 degree Celsius every second. So every second the temperature goes up by 1 degree. That's what change in temperature over time means. Okay, back to acceleration. Think of a car. Initially, at time t equals 0, it's just sitting there. And 10 seconds later, it's moving at, I don't know, 50 k's per hour. So that's what acceleration measures. Acceleration measures the change in velocity over time. So I'll rewrite A equals V minus U over T. Sometimes they'll use V sub F minus V sub I, where the V sub F is final velocity, F for final, and the V sub I is initial velocity, I for initial. But it's typically written like this. Now, you can rearrange this using algebra. You can rearrange for, let's say, V. To do that, you have to get rid of the T, times both sides by T. You get AT, or TA, which is the same thing. These cancel out, you get V minus U. So therefore, V is just U plus AT, because if I take this over, the minus becomes plus from algebra. So that here is another equation of motion. V equals U plus AT. Velocity V is the initial, so the final velocity V is the initial velocity U plus the acceleration times time. That's an important equation there, formula. This formula is given in the formula sheet in an exam typically. There's another formula, looks like this. You've already seen most of these symbols. That's the initial velocity here. That's the time. That's A for acceleration, half is just a number, and T is the time. Now S, what on earth is S? Well, S isn't speed, be careful. S is displacement. In physics, displacement is a measure of how far you are from your starting point. It's very simple. Let's suppose I have I draw a line, draw an X on, let's say, the footpath. And I call this my starting point. And I move, let's say, 10 meters to the right. What is my displacement? My displacement is 10 meters. Displacement is a measure of distance. It's sort of like distance, but with a direction. So 10 meters to the right is my displacement. Let's suppose I move 5 meters to the left. My displacement is 5 meters to the left. Here's a trick one for you. If I start at X and I go 10 meters to the right and come back to X, what is my displacement? If you think about it, you go 10 meters to the right and you come back, displacement is 0 because you're back at your starting point. So if you think about everyday life, if you start at home, you go to school, go back home, your displacement is 0. So this here's the second important equation of motion. There's another one, looks like this. V squared is equal to U squared plus 2AS. Nothing special here. U is the initial velocity, V is the final velocity, A is acceleration, S is displacement. These formulas, I can show you where they come from. It's not really fruitful for year 10. I can make another video on this, but you don't need to know where these come from, how to derive them. But you can derive these two formulas using things like V equals U plus AT, for example. But it's just nice to have some analogies as well to make sure you understand it. So this picture, what's happening, acceleration is the change in velocity V, change in velocity over time. You can rearrange it to get this here. This here is the formula to work out displacement, how far you are from your starting point. And this here tells you how you can work out the final velocity V in terms of displacement S, for example. I'm going to do another video with examples, but for now, these are the equations of motion given to you on the formula sheet. You now need to know how to use these. Not good enough, once again, to just know how to know what they are.